So here's a quick look at what the quotient rule is. The quotient rule says if you have some function that is the ratio of two other functions, so say h of x is f of x divided by g of x, then h prime of x, that's the first derivative, is going to be the derivative of the numerator times the denominator, minus the derivative of the denominator times the numerator. So that part of it is very similar to the product rule, except it's got a minus sign here. And then the other thing we're doing is we're putting in the denominator g of x squared. So let's see what that looks like in an example. So here's our first example. I kept this as an h of x. Didn't mean to do that. As an h of x. So I'm going to call this f of x and this g of x. So until my students get comfortable with just doing this on the fly, I have them write out f of x. Yeah, that's the numerator. So f of x is equal to 3x squared plus 4x. And that makes f prime of x equal to 6x plus 4. So we know how to use the product rule, or I'm sorry, the power rule. Next, let's look at the denominator. This is my g of x. So g of x is equal to 2x squared minus 15. So that means that g prime of x is equal to 4x. And that is it. So now I'm going to make my substitutions. I know that h prime of x is going to be the derivative of the numerator. So that is this, 6x plus 4. So let's put that in there, 6x plus 4. And I do need parentheses around that because it's going to get multiplied by the g of x from the denominator, which is 2x squared minus 15. So let's write that in, 2x squared minus 15. Then I'm going to subtract the derivative of the bottom, 4x, times the top. So that's my 3x squared plus 4x. 3x squared. Getting close to my notes there. So then it all goes over the denominator, the g of x squared. So that would give me 2x squared minus 15, the quantity squared. Now, depending upon your instructor, your teacher, professor, depending on if you're taking it in high school or college, you're going to maybe be done here, or you could simplify this out. So that becomes, assuming we have to simplify it out, let's see, I'm going to FOIL these top two here. So on the fly here, just foiling, I've got 18x cubed. Let's see, my outers and inners. I'm going to do the inners first because I see an x squared term there. So that'll give me a plus 8x squared. And then my outers, this is the O in FOIL, would give me, let's see, what's 15 times 6? 90. So minus 90x. And last times last. 4 times negative 15 is minus 60. And then over here, I'm going to go ahead and distribute this 4x. So let's do that. So 4x times 3x squared is negative 4, no, not negative 4, negative 12 x cubed. Nope, not a plus, that's a minus, because I have a minus times a plus. So that's minus 16 x squared. And again, that's all over the g of x squared. Looks like there's maybe one more step to this maneuver, and that is to add your like terms in the, got a crack on my screen right there, in the numerator. So I have, let me see here, I got 18x cubed minus 12x cubed. That'll give me a 6x cubed. Let's see, then I have negative 8x squared and negative 16x squared. That gives us a negative 24x squared. Let's see, last but not least, there's just a 90x, minus 90x, and a minus 60. And that is all over 2x squared minus 15x squared. Now here too, some people may simplify this. I don't simplify this because it's not going to divide into this that I'm aware of, but it doesn't look like it does. So at this point in time, we will call this one done. Example number 2 here. It's not h of x, but let's try to do this one on the fly if we can. So I'd have y prime or dy dx when I take the derivative. And that's going to be equal to, I always joke with students and say, I'll do the hard part for you. There. That's my g of x squared. That's just the denominator here squared. So that's part of the formula. So next I'm going to take the derivative of the top, which is minus 2x, times the bottom, 5x squared plus 3x, minus the derivative of the bottom. So let's see, what's the derivative of 5x squared plus 3x? I do believe that would be 10x plus 3. And yes, these parentheses do have to be here, or else it's not the right answer. You would be multiplying just 3 by what comes next instead of also the minus 10x. So what comes next is the top. So derivative of the top times the bottom minus the derivative of the bottom times the top, and it's all over the bottom squared. And then you could just simplify it or leave it like that, depending again on your professor. But I'm going to trust that you can do that algebra. So I'm going to go to the very next example, and then I'll be done for today. Here I'm going to have dy dx as well, because it starts with a y. So dy dx, or y prime. I mean, I could have written, y prime is also equal to dy dx. In any event, I'm going to, maybe here I'll write again, what is my numerator? Well, my numerator is my f of x. So that's 1 minus the cosine of x, making the derivative of the numerator equal to, let's see, this goes to 0, and the negative of negative sine x would just be sine x. Then, let's see, I'm going to put the denominator is my g of x. So I'll write that one out just real quick here. That's x squared plus sine of x. And g prime of x, because I'm going to need that, is 2x plus cosine x. I'm going to move that a little bit. So here we go. Let me write in derivative of the top. That is sine of x. Whoops, let me switch color again so it makes sense. That is sine of x times the derivative, that's the derivative of the top, sorry, times the bottom, which is x squared plus the sine of x, minus, okay, I'll go back to my base color here, minus the derivative of the bottom. So back to my red, that would give me 2x plus cosine x times the top, which is right here, 1 minus cosine x. So 1 minus cosine x. And I'll finish putting the bottom in, x squared plus sine x. So this whole thing just gets squared. Anything interesting going on there? X to the fourth plus 2x, x to the fourth plus 2 sine x plus sine squared x. Possibly, but I'm not sure. Up on top, I'm going to simplify this a little bit just to see if anything interesting happens. So my dy dx becomes x squared sine x plus sine squared of x. Oh, let's see. I'm going to do this in 2 moves. I'm going to FOIL this piece over here. Let me point at it. I'm going to FOIL these two, but keep this minus sign out here, and then I always have my students do that so they know that they're going to distribute that minus in the next step. So 2x times 1 is 2x. Let's see, my outers are what? 2x times cosine x. So that's a minus 2x cosine x. Then I've got my inners. That'd be just cosine x. Right? 1 times cosine x, sine x. And then last times last is minus cosine squared x. All over. We still have the same denominator here. This is x squared plus sine x. whole quantity squared. All right, I'll start simplifying the top here a little bit. X squared sine x plus sine squared x minus 2x minus minus is plus 2x cosine x minus cosine x plus minus times plus cosine squared x. And I had a hunch this was going to be going on. So here's my denominator, just recopying that. But what I notice in the numerator now is something kind of interesting. Sine squared x and cosine squared x add up to 1. So I may just change that to a 1. So that gives me, running out of space, but I'm going to do it. Let me put a 1 here, plus x squared sine of x. This and this added up to 1. Let's see, plus 2x cosine x minus cosine x. I suppose I could add those, but I won't. Minus 2x, and this is all over the the denominator of x squared plus sine of x, quantity squared. The only other possibility is some people may factor this cosine x out, leaving you with, let me just show you what it would be. If you factored out the cosine of x, you would have left 2x minus 1, but that doesn't really do much of anything for me as far as factoring, so I would just leave it as this, whatever's in the white. All right. That is the last example for today. So I hope you've gotten value out of this. If you have, please go ahead and smash the like button and make sure you subscribe so you can watch all of the upcoming videos. Talk to you next time. Thanks again for watching to the end. I appreciate it. That was the quotient rule, very similar to the product rule. So keep your chin up in school if you're struggling with this stuff. You got to make sure you pay attention, do the work, and never give up. So until next time, I will see you again.